Hi guys, this is Rohan from the Crazy Ones. Our sun is about 3.5 months old and will probably die in about 4 months, cosmic months. This idea of compressing all the universe's time span into one cosmic year was highly popularized by Carl Sagan in his series known as Cosmos. Now recently, Neil deGrasse Tyson also featured it in his series Cosmos, A Space-Time Odyssey, to be sort of the next season or next edition of Cosmos. Now, in this cosmic calendar, each second represents about 438 years. Each day represents about 38 million years. And each month represents about a billion years. To be precise, 1.13 billion years. And in this grand calendar, our human race is not even a full day old. Now, die for that sun doesn't refer that the sun will be covered in a tow, but it basically means that the sun will be converted into a white dwarf, which is a super dense, super tightly packed core of carbon and oxygen. Now, the thing that's keeping it from not collapsing anymore is what is known as electron degeneracy pressure. Now, this pressure is basically that the electrons don't like to be with each other and repel due to the negative charges. So this basically holds the core of the star. Now, after some time, the light of the white dwarf will also get down a bit and it will be converted into a black dwarf. But what will happen to a star 9 to 20 times massive than a sun? Well, the core of the star will get fused from hydrogen to helium, carbon, neon, oxygen, silicon and iron. And now the reason why it can't fit into more heavier elements, because there will be an absorption of heat, which is known as an endothermic process. Now the electron degeneracy pressure, the pressure that holds white dwarfs, will not be able to hold the core of a star, and a process known as electron capture will occur. Now this process, electron capture, basically means that electrons and protons will get fused into each other and form neutrons. Now, during this process, huge amount of energy will be released. Huge amount, tremendous amount. And this energy release is what is known as a supernova. Now, after the supernova, the remnant of the star will be a densely, tightly packed neutrons. And this is known as a neutron star. Now the thing that holds neutron stars is known as neutron degeneracy pressure, and this basically means that neutrons don't like to be in the same place or don't like to occupy the same quantum state. Now what will happen if you want to touch these stuff? Now I mentioned a link in the description. Check it out. It's supposedly the same question that I just asked. What will happen if you want to touch something like a neutron star? Now, a sugar cube of neutron stars will weigh about 1 million Earths. So yeah, it has a lot of gravitational grip. Now the diameter of this neutron star would be about a typical city, New York City for example, but the mass of this neutron star will be about 1.5 to 3 masses of sun or solar masses as they say. Now we have done enough research on neutron stars, white dwarfs, black dwarfs now. Now let's imagine what will happen to a star more than 20 times massive than a sun. It's a good question and I hope. Before beginning, let's see what we have learned till now. We know that a sun had lived approximately 3.5 cosmic months, which is 5,000 million years, and will die as a white dwarf, which will later become a black dwarf. A star 9 to 20 times bigger than a sun will form into a neutron star. But what will happen to a star more than 20 times massive than a sun? It will turn into a black hole. Let's see how a black hole is formed. Now for a star which is 20 times more massive than a sun, electron degeneracy pressure, neutron degeneracy pressure, and even theoretically quark degeneracy pressure after the bursting of star into supernova all break down into an infinitesimally small point known as a singularity. This singularity is so small, so dense, that all our physics, all our mathematics break down. The escape velocity of the black hole becomes more than light, thus becoming impossible for any object to escape it. Let's see why you should never fall into it. Black holes, in a way, are the dinosaurs of our universe. They try to rip, smash and crush every tiny bit of our cosmic material.
But this notion is partially correct because all the superpowers of black holes come into play when an object passes through the event horizon.
Absolutely correct, Anish. But still, like our earthly dinosaurs, we fascinate them. Let's start with our black hole. There is a boundary around the black hole through which nothing can escape. It is known as an event horizon. Now it is like a one-way travel and never returning back, or the way to hell. Now sometimes light just hangs on that event horizon, not even escaping and not even falling into the black hole. Now this circular disk of light of photons is known as a photon sphere. Now there is also a circular disk around the black hole. It is not like a photon sphere, but it is like a dump of cosmic garbage churning and churning around the black hole. It is a whirling superheated gas and dust-like particles basically orbiting the black hole. Now this is known as an exertion disk. Now turning back, someone in the black hole will see nothing. But what will someone see outside the black hole? Let's find out. So we have these two astronauts, Gordon Cooper and Buzz Armstrong. Now Gordon and Buzz decide that for their apparatus, they will send the intrepid astronaut Buzz Armstrong to the black hole and Gordon Cooper will record his measuring. So they decide that at atomically exact 11:00, Buzz will go into the star, which at that particular exact time have been formed into a black hole through which nothing can escape, not even light. So Buzz starts his journey at 10:50 until 10:59:59. Gordon is able to receive the signals, but the 11:00 signal, the last signal, will not be able to be received by Gordon because at that very moment the star would reach the critical radius through which it will convert into a black hole and the 11:00 signal will be absorbed by the black hole. But he would not see Buzz suddenly vanish. Instead, he would see him absolutely still and his light turning redder and redder and slowly disappearing. And for Buzz, he will get ripped, or as some physicists say, spaghettified due to the tidal force. Now this critical radius through which any object can become a black hole is known as the Schwarzschild radius. Every object has its own Schwarzschild radius. For example, our Earth has a Schwarzschild radius about a peanut, this much, or let's say Mount Everest. Mount Everest has a Schwarzschild radius of about a nanometer. In my recent video, I talked about a thing called space-time fabric and left them pretty mysteriously. Now a space-time fabric is a fabric which combines both space and time. Let me explain you more easily with a paper. Now suppose this paper is the 4-dimension space-time fabric and this wheel is our own star, the sun. I've held it tight. Let's see what will happen when I lose it. It has formed a dip and this dip is known as gravity. Any object in this space-time range of the sun will automatically attract to it. This also means that a dip in space-time does not only mean a dip in these spatial dimensions, which is x, y, z, but also in the temporal dimensions. So as we talked earlier in the video, we now know that a black hole has extreme gravity, which now means that it has an extremely deep dip in the space-time. This means that a dip also in the temporal or in the time dimensions, which means it is a way to travel through time. But the problem is that in the singularities, our mathematics, our physics and our mere sense of predictability breaks down. This is known as cosmic censorship. This basically means that God does not allow you to see all the amusements of the universe. Even if you survive through some godly or superpower, you may be able to see your future or past, but in terms of practical science, it is impossible. Now, in a realistic situation, we will never encounter with a non-rotating black hole, because as we learned earlier, black holes are formed from stars and stars spins. So we will always encounter with spinning or rotating black holes. These spinning black holes are known as curved black holes. These are a bit different from non-rotating or Schwarzschild black holes. These type of black holes literally drags space-time around them to form a gravitational whirlpool. Now, this whirlpool is known as ergosphere. An object in the ergosphere would have to accelerate in the opposite direction just to stand still. We can conclude that black holes contains two horizons, inner horizon and outer horizon. Inner horizon marks the surface of the actual event horizon, while the outer horizon marks the surface of ergosphere. However, an object can escape through a ergosphere. Subscribe, like and comment to the crazy ones.